Hello everyone, welcome back to my channel Saisha Tech. This is Amogh Kaliwal. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood Poisson's distribution and its applications. In today's video, we will understand definition of exponential distribution, compare exponential distribution with Poisson's distribution, understand where to apply different distributions, and application of exponential distribution. Exponential distribution is a probability distribution that describes time between two events in a Poisson's process. Now, what is Poisson's process? We will understand in the due course of the video. Probability density function for an exponential distribution at a random experiment x can be defined as p of x is equal to 1 minus e raised to minus n lambda, where lambda represents the average time between two events and n represents the time elapsed between the event. Now let us understand what is Poisson's process. Let us understand the series of events which takes place in Poisson's distribution. The mean time between the events is known and is constant, which means the average time of occurrence between two events is always known. Individual events occur at random and independently in a given interval. There is no dependency of one event to the other event. They are independent. Events cannot occur simultaneously. There is a small duration difference between the two events. As we can see, there are some of the common factors between Poisson's distribution and exponential distribution. Now, let us compare Poisson's distribution with exponential distribution and understand them in depth. Let us compare exponential distribution with Poisson's distribution. For comparison, let's ask the first question: why exponential or Poisson's distribution is used? Exponential distribution is used to understand how much time between given number of events. Similarly, in Poisson's distribution, how many events occur in a given interval. This can be clearly understood using example, like the number of minutes between new arrival of a person in a bar is exponential distribution. Similarly, the number of people arriving at a bar in 1 minute of time is Poisson's distribution. The random variables which are used in exponential and Poisson's distribution are here time, which is a continuous variable because it can take 2.3 seconds, 2.4 seconds and so on. In Poisson's distribution, it is number of events. Number of events cannot be a decimal value, they are integers, hence it is discrete. The parameter in exponential distribution is rate of occurrence, that is unit is time, whereas in Poisson's distribution it is number of events. The events can be a count of childbirths in a hospital or the count of vehicles passing through the toll booth, etc., which has no units. Hence, Poisson distribution parameter is unitless. Now we have compared exponential and Poisson's distribution. Let us understand where we can use exponential distributions. Let us understand where we can use exponential distribution with examples. It is mostly used for testing product reliability. All companies provide warranty and guarantee for their appliances like air conditioner, geyser, tube light, fan, etc. The duration of warranty and guarantee can be identified using exponential distribution. Similarly, how much time will go by before a major hurricane hits. Also, similarly, how long the transmission in my car lasts before it breaks. These are some of the examples of exponential distribution. Now let us compare exponential distribution with other distribution and understand where we can use each of the distributions. Let us compare geometric, binomial, Poisson's and exponential and understand in which cases which distribution we can use to analyze. Geometric distribution. For estimating the number of attempts before first success. If we want to analyze the probability of the number of attempts before first success, then we can use geometric distribution. Binomial. For estimating number of successes in n attempts. If we have 10 attempts and in that 10 attempts we want to know the probability of success, then we can use binomial distribution. Poisson's distribution. For estimating n number of events when on average we can see m events. As we know, the average number of events in a given interval of time, and if we want to calculate the probability for m events during that same interval of time, then we can use Poisson's distribution. Exponential distribution, it is time to failure. That is, if you want to know the probability of time elapsed between the two events, then we can use exponential distribution. These are some of the comparisons of different distributions. Now let us understand the exponential distribution with examples. We want to analyze the person's visit on a website. We have observed on an average 3 persons visit in an hour. Now we want to understand in the next 10 minutes what is the probability that a person will visit the website. To solve this problem, we have lambda is equal to 3, that is 3 persons visit the website on an average in an hour. We want to analyze in the next 10 minutes a person will visit the website, that is 10 divided by 60, that is 1 by 6, hence n is equal to 1 by 6. The probability density function for exponential distribution is 1 minus e raised to minus lambda n. Substituting these values, we get the probability as 0.3935, which means we have 39.35% that a person will visit the website in the next 10 minutes. Now let us understand the second example. We want to analyze calls receiving at a tech support center. On an average, we receive 5 calls in an hour. Now we want to understand the time elapsed between the two calls is more than 30 minutes. To solve this problem, lambda is equal to 5 as we have 5 calls in an hour and we want to analyze for 30 minutes. Therefore, n is equal to 0.5. The probability density function for the exponential distribution p of x is equal to 1 minus e raised to minus n lambda. Substituting these values into the function, we get 0.082. That is, we have 8.2% chances of gap between the two calls as more than 30 minutes. These are some of the examples of exponential distribution. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.